Okay, in the last video we just completed the first page, the body components. I just started. The body components is the main, the average. Here you can see the average young adult man, how much components, like how much body parts it contains. First of all, we can see the if 80% of the body weight is protein, because I have written here clearly. You can see 18% is protein, 18% is protein, 7% is mineral, 15% is fat, and 60% is water. And then here we are seeing about the just saw, and the water is divided into intracellular and extracellular component. In extracellular component there is blood plasma, which is outside, the vascular system, that is the circulatory system, which is plasma is 5%. And then we will be having outside of the blood vessels, that is the interstitial fluid. We have 15% of interstitial fluid and blood plasma. And then our total blood volume is about 8% of the body weight, which is like, which we have to know. I think this is it. Here we completed this thing, and I will be going for the next, that is units for measuring concentration of solutes. If we take it is important actually for knowing the thing called moles, equivalents, and acid, water, electrolytes, and acid base. This is like which we have to know. And then I think we'll go for the moles. Okay, first of all, what is meant by moles? Moles is a gram molecular weight. You have to just, its a definition is gram molecular weight, and 1 mole is equal to 6 into 10 to the power of 23 molecules or atoms or whatever. And then here we will be having some example. What is millimole and what is micromole? I have written here. This is millimole. For example, the molecular weight of sodium is 23 gram and the chloride is 35.5 gram. If we add together, if we addition together, then it is coming 58.5. So if it is 1 millimole, then we will be saying 58.5 gram. If it is 1 micromole, then 58.5 mg. This is it. And then we will be having Dalton. What is meant by Dalton? It is in that, if you read, it is over here. Dalton in this thing, it's here. You can see it's a Dalton. What are important? I'm just trying to tell you only that I just read, and I'll be telling you like what are all important which you have to know. Okay, see, Dalton, it is a unit mass equal to 1/12 of the mass of an atom of carbon 12. It is 1/12 of carbon 12, which is, this is it. This you have to know. And then we'll be having, going to the equivalence. Equivalence is a thing which, what you have to remember, 1 mole of ionized substance divided by its valence. It is like, it's like, it's nothing is there. Even like, see, 1 equivalent is 1 mole of an ionized substance divided by its valence. It's that one. And after that it will be going water, electrolytes, and water, electrolytes, acid, base. This is this one, I think. Yeah, okay. And here if we take the water, it is a high surface tension. Okay, water has a high surface tension, water has a high heat of vaporization and heat capacity, and water has a high dielectric constant. What is this meaning? Water, you already know, it has high surface tension, which we all know, and water has a high heat of vaporization. See, if we can't take anything and we can just heat it up, and water we can heat the water, and it has high vaporization and heat capacity also. It can tolerate high capacity of heat also. That is it. This is the point. What has dielectric constant? We can even electric the conduction of current also takes place. It has high dielectric constant also. So that is it. According to the Lemons terms, water is an excellent biological fluid. It is just like that serves as a solute. It provides optimal heat transfer and conduction of current. This is it. And we'll take next, we'll go for the electrolytes. What are electrolytes? Like potassium, sodium, calcium, magnesium, chlorine, bicarbonate. These are the electrolytes. It is this, all things are widely distributed in body and fluids, everywhere in body fluids. And then this is it. and then we'll be taking pH and buffering. What is pH and what is buffering? pH, its normal pH of body is 7.35 to 7.45, and then the gastric fluid pH is 3.0, and then pancreatic secretion pH is 8.0, and then we will see pH is slightly alkaline, which is it's alkaline. Okay, here we are seeing the in the clinical box too. I think here we completed this page, I think. Yeah, here we are saying about the acid base disorders. Over here you can see here the acid base disorders is there. Acid base disorders is the, you can see, excess of acid or base um, exist when the blood is outside the normal pH range. The normal pH range is, we already know that pH range is 7.35 to 7.45. Okay, see, if excess of acid is accumulated, then it is called acidosis. Excess of base is alkalosis, which we know, and the normal pH range is 7.35 to 7.45. And then we have this thing so called and what we have to know, I think this is it. And okay, for example, if we have a respiratory acidosis or respiratory alkalosis, this is the diseases. And the metabolic acidosis and the metabolic alkalosis. Metabolic acidosis and alkalosis can be caused by electrolyte disturbances. The symptoms are severe vomiting and diarrhea, indigestion of certain drugs and toxins, kidney disease, and diseases that affect normal metabolism, example diabetes. This is it, acid base disorders. And the treatment of acid base disorders, we can give like for in case of respiratory acidosis, we can give mechanical ventilation, which is over here. And in case of metabolic acidosis, we can give chloride salt, and then can restore acid base balance to a normal level. And then we can give also chloride responsive metabolism, chloride resistant metabolic, so requires treatment for the underlying cause. We have to know the underlying cause, then we can treat the patient. This is it, and we can, this electrolytes is completed. I think acid base disorders, like if we have like high acid, then it's called acidosis and alkalosis. And this is it, acid, if we have excess of acid called acidosis, if we have excess of base called alkalosis. And this is it. And normal pH range is 7.35 to 7.45, which we have to know. And then we have here, we have the buffer capacity. The buffer capacity is just the thing which is like, Anderson, it is a substance that has like the ability to bind or release hydrogen in such solution, thus keeping the pH in the solution relatively constant despite the addition of considerable quantities of acid or base. This is the main thing to that, which is we have to know this thing, Henderson-Hasselbalch equation, which is over here. You can see here the Henderson-Hasselbalch equation. If we take the weak acid, that is Ha, plus water, which is relatively constant like thing, which is called water, and if we take this both, then it divide, it's a, the reaction takes place called H3O plus and A negative, which is anionic group. And then we are adding the constant Ka. If it comes, the Ha comes here. Okay, see, we have H constant, it's constant, so we are adding Ka also, and the Ha comes here, and then we are going, then the Ha goes here again, which the Ka, and then will from here, from A negative, it comes here, and then H3O plus, we just like changing the place only, that's it, misplacing the place. Okay, see, H3O plus come here, and here it goes here, and then we are just logging the, according to the log AB formula, just log AB is equal to log A plus log B. According to that formula, we are just logging this formula, log H3O plus log, just whole log, that's it. And then now it comes like log Ka, and it is divided into log Ha by minus, and we are multiplying by -1 both the side. So if we take minus, then we'll be like dividing this thing, and then now we have like pH. For this we have pH, and then pKa minus log and this thing, and then according to log A by B is equal to minus log B by A, pH is equal to pKa plus log A minus by HA. This is it. This is the buffer capacity, and we'll go to the diffusion. For example, if we take the diffusion is just the thing so called like diffusion. What we have to remember in diffusion is like, if we take this diffusion, what is diffusion? Okay, for example, I'll be telling you ink and water. If we take ink, see, it is a ink drop, and water is over here, water. If we take water and ink, this both things combine together. Ink has higher concentration thing, so it will change the water in all, the water into blue. So ink is high concentration and the water is lower concentration, so both infuses together and they form uh, like the water changes into blue. So this is like diffusing thing, like higher concentration substance ink and lower concentration water both diffuses, and just the diffusion takes place over there. That is the main concept of diffusion. And then we have fixed law of diffusion is equal to, I have already told you that the fixed law of diffusion, J is equal to, which is the net rate of diffusion, and then D is the diffusion coefficient, and A is the area, delta C by delta X is the coefficient gradient. This is the formula for fixed law of diffusion. Okay, and this is the thing. See, concentration gradient, sorry, diffusion, which is the higher concentration thing, comes to the lower concentration, and then both infuse together and changes the thing into a solute, and then it is the diffusion. That is that time that all water changes into the higher concentration thing, that is called the net flux. Okay, which is over here. That is the diffusion. And we have osmosis. If we take for the osmosis, we will be seeing, okay, we will just complete this topic and we will just discuss this osmosis in the next lecture. Okay, bye. Please do subscribe my channel so that you will be like having all this Genon's physiology studying with me. If you have any solutions, or if you have if I am mistaking something, just try to help me. If you're I'll be telling each and every pages like this, so it will be more easier for you, I think. And what are all important, I'm just telling you. So just and in the next video we'll just say about the osmosis, and it will be easy for you guys also, and it will be helpful for me also. What are all important, just let me know in the comment below, or just please help me for studying, because I'm just really preparing for MSA so hardly. So thank you guys for watching my video. Thank you for patience that whatever I explained, just you are hearing that. I think I'll be so happy for hearing this type of things. So thank you so much. Please do subscribe my channel. Bye.